Good morning to everyone. Finally, we have explored the topic on functions. We have seen how to define a function, how to call a function, how a function can be defined recursively, right? Calling the function within the same function. That is to be a recursion. And we have seen several examples of using functions, including a recursion. Now let us recollect the same. First, see what is a function. We call what is a function. Function is a sequence of statements which are used to achieve a specific task. Sequence of statements which are used to achieve the specific task. Whenever we need the same set of operations are to be executed at different places, we can call a function. So whenever we call a function, we need to define its name. Function is distinguished by its name. So we need to define a function using this general format: return type, function name, parameter list, then within the opening and closing curly braces, we need to define the function definition. Our function statements will be defined within this opening and closing curly braces. Return type signifies what type of value is returned from the function. Say void, right? No value is returned. Integer, character, float. Then specify the name of the function, because we can define several functions. So when we define the functions to distinguish one from another, we need to have its unique name. So function name defines the name of the function. Then specify the parameter list. The parameter list defines the formal arguments, or these are called formal parameters. Parameters declared in the function definition within the parentheses, opening and closing parentheses, are said to be the formal arguments or parameters. We need to define the statements of the function within this opening and closing curly braces. So once we define the function, we need to define its prototype. Function prototype. Function prototype, this should be defined before the main function section. Since we are defined the functions or function following the main function section, we can call a function in another function. Say main can call a function. So that stage, what we have to do, we need to make the function prototype. Function prototype, this is defined with respect to this general form: return type, function name, type, parameter list or type of parameter that should be separated by the comma operator. Then finally end with the semicolon. This is to be the function prototype. This is required just to inform the compiler that the function name is defined following the main function section. So please recall that function prototype, this will be defined before the main function section, just to inform the compiler the function is defined following the main function section. If we have multiple functions, all of the function prototypes must be defined before the main function section, but we inform the compiler that the functions are defined following the main function section. Then to call a function, simply we need to use the function name. How to invoke a function call? Specify function name, then specify the parameter list. The parameters defined in the function call statement, these are said to be actual arguments or actual parameters. During the function call, actual parameters are assigned to the formal parameters. Then formal parameters can be processed within the function definition. The function can process something within that and it may return a value to the calling phase. That stage, a function can return only one value to the calling phase. That means at the maximum, function can return only one value to the calling phase. Minimum, right? If it does not like to return the value, right? So that stage, the return type is void because the function would not like to return a value to the calling phase. So return type is void. So zero value is returned from the function. Whenever it returns a value, you must have a proper return statement, return expression, so that the expression is evaluated and the value is returned to the calling phase, so that the function call statement can be placed inside a printf statement, or we can assign the left-hand side variable so that the returned value from the function can be assigned to the left-hand side variable. The number of actual and the formal parameters should be same. That means there must be a one-to-one correspondence between the actual and the formal parameters. So please recall a simple example. For example, hash include stdio.h int main. Here have a function, for example, void f, have a printf statement, printf slash f. I am inside the function. Save the file, then compile it F9. No compile time error is reported here. Control F9. What happens? No output. Because here this is the main function. For example, finally have a return statement, return 0. Initially have return slash f. Main starts here. F2, F9. Control F9. Main starts. That's all. I am inside the function. The message is not printed. So this stage, what happens? Since the function f has not been called, so you will not be able to execute its operation. So I am inside the function. This will be displayed only when the function is called. So in this case, even you have several functions, void f, void g, fetch, method. We have missed to write even the function prototype. So when actually the function prototype is required, please understand, when we call the function, for example here, we have the stage, program execution begins at the main function. Sequential statements are executed. For example, main starts. That stage, right, you are trying to call the function here, so that the compiler will not be know what is f. So this stage, it is mandatory to inform the compiler that f is a function that is defined following the main function description whose return type is void, function name is f, actual to formal parameter, right, mapping, or simply the parameter list of function definition is simply right FP. This function prototype is required. So please recall this is the function prototype. Function prototype, this is simply the function declaration. This would be made right before the main function section to avoid the compile time error. So this stage we have got the output. Main starts, then the function f has been called so that we have the message I am inside the function f. The function f can be called any number of times. Whoever can call the function f. Next, see right what happens when we miss a function prototype and when we define right the function before the main function section, right? Let us check right if it is possible, right? Why? Hash include stdio.h. We are trying to define a function before the main function section, say void f. Since this is a free-form language, I like to define the statements in a single line. For example, printf slash n inside the function f. Void g printf slash n inside the function g. Next, let us write the main function into main return 0. Let us define one function here, say into which. Let us return one integer, say return 12. The main function, first let us compile file save us F9 5 errors return 12 return 12 semicolon F2 F9 3 errors. Can you point out the errors? Can you fix the errors? Hash include stdio.h.
Sir, you didn't include that h function in the beginning, sir.
Which function?
H function that is not
H.
included in the starting.
Okay, that's what right we discussed just now. We are not calling the function h. Function prototype is required only when the function is accessed. For example, in the main function, if we try to access a function h, then we can declare, right? Then we must declare it's a prototype. Here, can't we find out the error? Opening curly brace. Here, closing curly braces. Let's see. Here also closing curly braces. F9. What happens? What is missing additionally? Can we find out the errors? The lines are written in the same line, that's all. To avoid the confusion, we can follow the normal style. Now it's not time for you, right? You need to tell what are the
Sir,
comparative.
semicolon is missing inside that curly braces, sir.
Very good. That's the correct one. Semicolon, right? This will not be defined like this, right? Following the closing curly brace, semicolon has been put. Here you need to take semicolon. There also put semicolon. Let me save it again. Pressing F9. Fine. Program has been compiled. Control F9. We can't expect any output because in the main function, no executable statement is there. In case if it has given, for example, F, then I do like to call a function stage control F9 inside the function F, inside the function G, because the functions F and G are called. H has not yet been called, so to call a H, F9 or F2, F9, what happens? The compiler reports the error message. The error message is call to undefined function hatching function name. So please note the error message carefully. Hatch is taken as an undefined function. So what about F and G? F and G are right functions which are completely defined before the main function. That stage function prototype, right? There is no logic of having function prototype. Since the functions are right defined before the main function section, we can call a function, right? F and G. For example, here function hatch is defined. If you want, you can also access the function F and G, right, inside the function hatch. But hatch is concerned, hatch is called inside the main, but hatch is defined following the main function section. So before the function call, it should be informed to the compiler. So here, right, for example, let us try to define its prototype. Prototype is the if H semicolon F9 browser control F9 inside the function F, inside the function G. But H here what happens? H we have called the function. Even we have executed right this kind of statements. Function has been called. Yes, that's true. Return 12. 12 is returned to the calling phase. No compile time error. We have already uh, said the same thing, but the left-hand side variable is missing. Uh, this should not, this is not even right printed inside the printer statement. In case if we have to write like this, the return value is processed here as in the highlighted place. Then it gets printed further in percentage D format specification so that we can get a result as 12. So please recall that functions may also be defined before the main function section. That stage, there is no need to use the function prototype, right? For example, here I can call function F inside it. Now have a look into this outcome. Main right begins its execution. F has been called. So first line we expected the message inside the function F. Then second, the function G has been called. So inside G, first we have called the function f. So here we can expect the message inside the function f again. Then printf inside the function g. So that is printed. Then thirdly, right, the printf function calls the function h. H returns a value 12 here because of simply one return statement, return 12. The returned value is processed in the printf statement. So the value 12 gets printed. So please recall that a function prototype, this is required only when the function has been properly called. So when you do not like to call a function, that's it. Function prototype is not expected. Second thing, functions may also be defined before the main function section. That stage, don't define its function a prototype. For example, here, again we try to define void here, F9, no compile time error, void C, F2, F9, no compile time error, but unnecessarily we have provided the function prototype. That means function declarations, right? Not necessary. Understand? Have any doubts in this example? Have any doubts?
Sir, I have general doubts. Sir. We can
Yes.
give the curly braces in single line itself also, no, sir? There
Within
won't be curly braces we can give in single line also, no, sir?
this one, yeah, you're asking to write a function definition like this, am I right?
Ah, yes, sir. There won't be any problem, no, sir.
No problem. We have already discussed this several times because C is free-form language. Even void G, right? And define the functions like this. I say find save after the modification F9, no compile time error, control F9. We are getting the same output. Only thing is C is C is a free-form language. That's what, right? You can write a code, right, even in a simple line. It will work. Another thing, we do not like to write or define the functions before the main function itself. Because one important feature of a C language is structured as a top-down programming language. So let me write in comment. Top-down programming language. Top-down programming language means main is expected to define at the beginning of the program, top of the program. Following that, the user is allowed to write any number of functions. Because we know that program execution begins at the main function section. Just to recall, here, right, this is the main function section. Following the main function section, assuming that this is equal to me, we can define any number of functions. Say function 1, function 2, etc. function n. Since the main is defined at the top of the program, from there we can call the functions, say f1, f2, then we can call the function f3, f4, etc. fn. Since the flow is from top to bottom, this is said to be a top-down programming approach. In the next semester, we will learn like C++. Where in C++, main is defined at the bottom of the program. Before the main, we need to complete the class definition, class section definition, right? Completely to be defined. Since there, right, main is defined at the bottom of the program. From the bottom, control goes in upward direction, right? So bottom to up direction. That's what the C++ is said to be a bottom up programming approach, or even you can write a C++ program like a C program using top-down programming approach. But in the case of C language, right? So when we like to follow the top-down approach, main must be defined at the beginning of the program. So conveniently following the closing curly brace of main function section, we can define any number of user-defined functions so that the flow of code follows the top-down programming approach. Next, let us see what are local variable and global variables. Before going to see, right, what are storage classes? Let's explore first, right, what are local variables. First, local variable. Local variable is a variable. Local variable is a variable defined within a function. A variable defined within a function is said to be a local variable. The examples of local variables are function parameters. Function parameters that we mean formal parameters are completely local variables. So in this example, let us illustrate what are local variables. stdio.h into main. Let's have some functions return 0. Suppose void. First, this is one function. Void and this takes one integer parameter, say int a. This is another function. Let us declare its prototype, say void first, then void again. Its a return type, sorry, its type is inner, right? Type int is inner. You need not define int a or even int b, int c. Anything you want, right? You can define. Now inside the main function, I have one variable. Suppose int x. X is equal to 10. You can print the value of x here. Print slash n. X is equal to percentage d to x. Then let's call the function first. Then call the functions again. Let's have one variable inside the function first as a int y. Y is equal to 20. Writing the value of y here. Print slash n is equal to percentage d comma y. Then have the second function, this one. Print slash n is equal to percentage d comma a. Even we can update the value of a is equal to a plus 100. Then print the updated value of a, printer slash n updated a is equal to percentage d a. Pass one integer value, suppose second of 0. Now what happens? Let's save it first file, save cpc. Have a look into this example. Int x is equal to 10. X is defined within a function, right? Within this opening and closing curly brace. So this x is said to be, this x is local with respect to the main function. Hope you understand. X is local with respect to the main function. So within this opening and closing curly brace, wherever you want, you can access the variable, access the value of variable, or simply access the variable x. So here we have printed the value of x. For example, inside the first, here x is not accessible. X is not accessible here because x is local to main function. Same way here inside the function second, x is not accessible here because x is local to a main function. Try to write a printf value of x right inside the first and the second. For example, printf hash here x is equal to percentage reading mark x. For example, we try to access the variable x inside the function first. If we save the file right as saved right okay by F9, file has been compiled. What is the error message? Have a look into this error message. Undefined symbol x in function first. So undefined symbol x right in the function first. So in the function first, right, if you try to access the variable x, x is not possible because x is declared right inside the function main. You cannot access the variable x in other functions. That is the problem. So this results in the error message. Likewise, here the variable y is declared. Y is accessible only within the function first. Within this opening and closing curly braces, we can access the variable y. Next, considering the function second, here one variable a is defined. The variable a is the formal parameter. Formal parameter that is a. This is taken as a local variable. So within this opening and closing curly brace, I mean here within this opening and closing curly brace, the variable a is accessible, and you can update a value a, right? Whatever you want, you can do. But outside the scope of this opening and closing curly brace, for example, even in the function first or even inside the function main, you cannot access the variable. That's the thing. Control F9. So clearly we have the output x is 10, then first have been called y is output. So x is local with respect to the main function. Y is 20, y is local with respect to the function first, then first, second, right? The second have been called. Initial value of a is 0 is printed. Updated value of a as we have done, a is a plus 100. We expected the value of a is 100, but the value of the variable a, right, or simply a cannot be accessible inside the function main because a is local with respect to the function. Again, in case if here, right, if I do want to modify the actual parameters, it's second is. Now what happens? The value of x is 10. 10 is possible here. So simply here, a receives the value of x. X is 10. So a is 10. A is returned here. A gets updated to 110. But in the reverse, if you try to print the value of a or value of x, right, inside the function main at the end, after calling the function. The change made in the formal parameter, say a as 110, this will not be reflected in this variable x. For example, I try to call the printer statement again, printer slash n x is equal to percentage comma ax space 110, right? Even updated only in the variable a as 110. After calling the function, please don't think that x and a are same. Certainly not. X is a local variable with respect to a function. A is a local variable with respect to a function second. Even though a receives a value of x, this does not mean the changes made in a will get reflected in x. No. Changes made in a as say 110. Here updated a is 110. This will not be reflected in the variable x here. X remains a value 10. Actual parameter will not get actual parameter, we mean x here. When calling it results again, will not get affected because the variables are completely local. Right? Even here, instead of int a, even we can have a variable x here. Please understand, I do like to modify if the variable, right? A into x means there is no issue here. X is printed, x is equal to x plus 100, updated x is simply x. This x is local with respect to the functions again, but this x is local with respect to the function main. So changes made in the variable x as a local variable of second function will not modify the value of x in the main function, right? Because x in main is said to be a local variable with respect to main. In case if the a is changed to x in a function second, that x in second is said to be a local with respect to the function second. So this way, the variables declared in a function are said to be local, so that local variables can have a scope only within the opening and closing curly loop. Outside the defined scope, local variables are not accessible, right? Understand or not? Have any doubts in local variables?
Sir, I have different doubts. When should we use void and when should we use int sir for function?
Good question. In case whenever you like to return a value to the calling phrase, as we have seen in the previous example, for example, int h. In int h, we do like to return the integer value to the calling phrase. That stage you can use the return type as integer one. In case if you want to find out only the computational and printing, right, everything inside the function definition, we can use the return type as void. For a better example, I like to say if you want to find out the average of n numbers, assuming that in the function definition you are finding the average of n numbers. One user would like to print the average within the function definition after the processing. No problem. That stage he should make the return type as void. In case if you are interested in returning the value to the calling place, suppose average, x bar, and the value of x bar is further being processed in the main function, there you need to return a value of x bar. That stage, you can make return type as, for example, a floating point one. Because x bar the average of some n numbers. After finding the average, the function has returned its value so that the average x bar can further be processed in the variance or standard deviation calculations. For example, standard deviation is equal to square root of summation I is equal to 1 to n xi minus x bar whole square by n. There the numerator xi minus x bar whole square. X bar is the mean of n numbers. So there we need to find the mean, and further the mean should be processed in finding the variance or standard deviation calculations. There logically we can return a value to the coordinates. In case of the problem is just find the average of n numbers. So after the computation of average, we can directly print the average within the function definition itself. Since the value average is not being processed further in the call place or even in the main function. So make a return type as a void one, void compute average. So finally, you need not return a value to the coordinates. So based on the situation, requirements, we can make the correct return type, void or other than void. Clear?
Yes, sir.
Okay. Next, we are moving on to write what is called a global variable. I write in the next example. Global variable. Global variable is a variable defined for the main function section. Variable defined before the main function section is said to be a global variable. Global variable may be serialized. If not, a garbage value will be the result. Let us check right. Hash include stdio.h. Let us define a global variable, say characteristic int strength is equal to, for example, 55. Then defining a function int name, assuming that one function void print, for example, some variables are going to be printed here. Let us write the printf statement. Printf ch is equal to plus, sorry, ch is equal to percentage c, comma, ch. Printf strength is equal to percentage d strength. Even we can update a value of strength plus plus. Then printf hash can updated strength is updated strength is equal to percentage d. Let us have the same right in the main function. Edit copy, edit paste, slash n, main ch, edit b, main strength. Let us say, since we have defined the right two variables ch and strength, these are taken as a global variable. C3 is C1, F9. Okay. Each include stdio.h, char ch. What is ch? Ch is a global variable. int strength is equal to 55. What is strength? This is a global variable. This is initialized to the value 55. Then inside the main function, let us declare this prototype print var. Let's call print var here. Then return 0. Need to fix the errors. This one using 20 degrees. Type. Okay. Have a look into our variable CH. CH is a global variable because the variable is defined before the main function section, but it has not been initialized, which extracts some garbage value in the primitive. Int strength is equal to 55. 55 is the integer variable and its initial value is 55. Sorry, strength is the integer variable, its initial value is 55, right? So this is said to be a global variable. Strength is a global variable. CH is a global variable. Print var function prototype. We do like to print the value of CH and the string inside the main function. We do like to call print var. There we do like to print the value of CH and the string. Updating string, and we are printing the value of the string. Now let's see its effect. F9. Control F9. Please see the flow of execution. When the control enters into the main function, initial value of CHA with respect to main CHA, something, right? I can find a CH is equal to percentage C, right? Nothing gets printed because we are not initialized, right? So let us initialize a value so that CH is equal to control F9. Okay. First, the value of CH, right? The CH is equal to check it, right? Please caps Q, okay, is printed. Then main strength. Strength is 55. Because please understand, so far we have declared the variables locally with respect to the main function. So even right within the opening and the closing curly brace of main function, at its beginning, right, we use the right to declare the variable, say character, CH, int, x, y, etc. In this example, these are variables which are completely defined before the main function section. So these are said to be global variables. Global variables can be accessible anywhere within your program. That means we can access them inside the main function. We can access them right inside the user-defined functions, right? So wherever you want, we can access the global variables. That is the advantage. So first main tries to access the global variable. CH is equal to Q is printed. Strength is equal to 55. 55 is printed. Then we have called the print var function. In the print var function, what happens? The CH is printed as a Q. Then strength is printed. Strength, right? Current value of strength is 55. Strength plus plus. Updated strength is printed. In case update here, the updated strength is right 56. In case if we like to have the same statement, right? After print var inside the main space, okay, it should be really print up updated strength in main. Updated strength in main. Now let us check right what happens. Strength is what one? A global variable. We have periodically accessed the global variable in the main as well as print var function. Initial strength is 55. Then inside the print var, strength is 55. Then strength is updated to 56 because of the strength plus plus. So strength plus plus updates the value of a global variable. Then control comes back to the main function where this line carefully understand main colon updated strength is strength. Strength is updated to 56 because only one time memory allocation is done for the variable strength. Initially 55. In the function definition, this is updated to 56. Then when the control again enters into the main function, updated value of strength is taken. Why? Strength is a global variable. Only one time memory is allocated here. That's what this line updated strength is 56. Understand or not? Have any doubts in this example?
Sir,
Yes.
return type is void only, no sir, here, but printf statement is in main function.
Return statement is here. We have void print var. We have put void print var.
No sir, in main function you are writing printf and updated strength equal to, like,
Yeah, you are having a confusion, right, in this line. Am I right? Yes
Yes,
or
sir.
no? Okay, I explained, right? And another way. Have a look into write this example. In this example, we have defined the variables, say ch and the strength. So pictorially, please consider this one. Two variables, ch and the strength. Ch, assuming that this is the memory location. Strength, this is the memory location to store a value of strength. Initially, we said that, right? Ch is equal to q, I think. Yes, ch is equal to q, strength is 55. So have this ch is q, strength is 55. These initializations are done before the main function section, and these are the initial values. Wherever you want, you can access these variables. That means ch and strength can be accessible inside the main function section. With respect to our program, we have defined a function print var. So print var can also access the variables ch and strength. Sequentially, in the main function, first we have printed the variable ch and strength. So here ch is q, strength is 55. These are printed. Since these are global variables and can be accessible within the main as well as in any of the user-defined function section, in the print var, first we tried to print the current value of ch and the string. So the first two printf statements prints first, right, q, then the second printf statement prints the current value of string plus 55. Hope you understand. Then have a look into the strength plus plus. In print var, we have a statement strength plus plus. Because of the strength plus plus, what happens? Strength is a global variable. It's content, right? 55. This is incremented by 1. Now the global variable strength, this becomes 56. Substantially control will not return any value to the calling place. Please understand. Print var execution is over. What print var did? Print var simply printed ch and string. Then it updated the value of strength. So print var updated a variable string, that is 56. Following that, no executable statement. Return type is void, so no values returned from this function print var. Following the function call statement. This is the function call statement. Following this function call statement, the next statement executed is this one, printer slash and main updated strength is. So understand here, main updated strength is 56. There is no connection from function returning to this printer statement. No value is returned from the function print var. First understand that because of its return type is void. We are not returned the value strength from the print var function. Instead, strength is a global variable. As we drawn here, this can be accessible anywhere within the main function as well as print var function. Even print var updated value of strength to 56. Then control comes out of print var when it re-enters into the main function. We tried to print the value of part 1 strength. That is the meaning of this printer statement. Print of updated strength is %d, comma strength means. Strength is a global variable, only one-time memory allocation is done. Now, when a main prints the variable strength, it prints the value 56. That's what here you can see the message. Updated strength is 56. Then if you call a function again, right? For example, print var, the value of strength is 56. Then 56 plus 1, 57. This way, only one memory allocation. That memory allocation is a global memory allocation, so that global variables can be accessible anywhere within the program. Whoever can change its value, that we mean main may change the global variable value. Any of the user-defined function, right, can also change the user-defined, the global variable, right? So this is the logic of difference between local variable and the global variable. Clear?
Yes, sir.
In this example, we used a global variable strength. In case inside the main function, one variable strength is defined, as we defined earlier, one variable x. In the print var, one variable x is defined. X in main is a local variable with respect to main. The variable x declared in print var will act as a local with respect to a print var function. So there, 2 times memory is allocated, one x right with respect to main, and another local x with respect to print var. Even the variables are same. Locally, twice memory allocation is done for 2 different variables. But in this example, strength, right, this is used both in main as well as the user-defined function. So what happened? The global variable strength is taken in both main as well as the user-defined function. So only one-time memory allocation. Global variables can be accessible anywhere within the program, but local variables are accessible only within the scope of the function. That means only within the scope of the defined function. That's the difference between local variable and the global variable. So having this fundamentals, differences between local and global variables, we will move on to the next topic, the storage classes. There are 4 different types of storage classes. They are auto, static, register, external. The variables, right, these are the keywords, auto, static, register, external, which are used to control how to define the scope as well as lifetime of the variables. So to define the scope as well as lifetime of variables, we need the storage class concept in C language, so that we will explore how the variables are going to be accessible within the function or within the program. How long, hope you understand, how long a variable retains its value during the execution of the program. That is a lifetime or longevity. Scope, right? That is said to be visibility. So to explore the scope, right, as well as the lifetime of the variables, we need the storage classes, which are supported with the keywords auto, static, register, and external. We will explore, right, those keywords in the next session. Have any other doubts? Okay, thank you very much. We will discuss in the next session.
Sir, how to write menu-driven program in C, sir?
Menu-driven programming. Menu-driven programming, right, can be written in a better way using, right, GUI-oriented languages like Java, VB.NET, C#, like that. Here, right, menu-driven, since there is no such appearance, we can write control through some formattings. We can write the options, right, file something or edit something, menu something, submenu something. We can display something, and from which, right, we can request the user to access which menu. For example, press F to access the file menu, or press E to access the edit menu. So we can give some directions. Using the directions, we can execute the operations just to simulate the menu-driven approach. Clear?
Yes, sir.
Okay, thank you very much. We will discuss in the next session.
Thank you, sir.